Hey.
Hello, everyone, and welcome. Thank you very much for joining us for today's webinar on interactive cargo. So the episode 4 of the IATA Digital Cargo webinars, replacing the Digital Cargo Conference held in Geneva. My name is Sonia Benhamida, and I'm the Project Manager Interactive Cargo at IATA. First, we would like to thank our sponsors. We have our main sponsor, IBS Software, as well as Pay Cargo and Reg Software for supporting this event. We have competition law guidelines. That's why we cannot discuss any element of prices, including fares or service charges, commissions, marketing plans, group boycotts, and any other issue aimed at influencing the independent business decisions of competitors. So if we do talk about these topics, we would have to close the webinar. So please don't ask questions about these topics. So how to participate during this webinar? We'd love to hear from you, so feel free to ask any questions or share your comments during the webinar. Type them into the question box in the control panel. And we will have time for questions at the end of each presentation, so 2 minutes after each guest speaker. This webinar is recorded and will be available on the IATA Cargo Events webpage. So today I will start presenting the IATA Interactive Cargo project on Making Cargo Talk. Then Paul Rodwell from On-Asset Intelligence will explain how the use of connected devices will revolutionize the air cargo journey. Then Maria Poveda from the University Polytechnic of Madrid will share with us the ontologies for the Internet of Things and gives an overview of and lessons learned from success stories. Then Liam Ford from Ericsson will talk about the importance of common data model for the IoT in logistics. Then Maite Iningwe-Ziarza from the European Aviation Safety Agency will talk about allowing portable electronic devices operation in an aircraft. Then followed by Timo Stadler from Airbus on what the progress has been made in the certification of portable electronic devices on board aircraft. So now I'm going to start right away with the presentation of our IATA Interactive Cargo project. The time to prepare for COVID-19 vaccine transport is now. So air cargo plays a key role in the distribution of vaccines and pharmaceutical products through time and temperature sensitive distribution systems. So how can we make sure that these capabilities are enabled? Air cargo is also essential as for cross-border e-commerce. So airlines must transform to meet the needs of the shippers with high-speed shipping, transparency, reliability, agility, and consistency in the delivery. So how can we make this happen? Our vision is to equip airlines and the air cargo supply chain with responsive air cargo services based on intelligent systems in order to enable self-monitoring, sending real-time alerts, responding to deviation to meet customers' expectations, and reporting on the cargo journey by adopting a data-driven approach. That is why the goal of the Interactive Cargo project is to provide stakeholders in the air cargo supply chain with a set of standards and guidance documents to enable and ease the use of connected devices for cargo interactions. The first objective is to characterize interactivity. What do we mean by interactions with cargo? What do we expect? And what are the data elements that we want to capture through these devices? So we are working on the ontology for connected devices for air cargo, as well as its implementation to capture and share such data through the one record data model that we are building. The second objective is around device certification. So how to simplify and safely approve the use of devices on board of aircraft. So today there are many different processes, and we want to bring clarity and provide simplification in this defining a standardized device approval process so that it's clear for device suppliers as well as for airlines. The third objective is around data use agreement. So what can we do with such data? Who are the owners? What can we do and cannot do with that? The fourth objective is to run pilots in order to validate operationally the standards and guidelines we define through the two first objectives. Now let's zoom in into the first objective. The question here is how to integrate interactive cargo requirements into the one record data model. So we first captured the business needs. So we wanted to understand what interactions we want to achieve with cargo. And also, what do we want to capture? What do we want to measure? Temperature, the humidity, and so on. Then from that, we identify the data elements that are required, and we are defining and aligning on a common language in order to create this common ontology around IoT and to integrate these data elements into the one record data model. The second objective is to set up a standard certification process. So first, we did an as-is analysis to understand the technical constraint, the regulatory framework, and the current certification processes. And from that, identified the pain points and the industry challenges. And from this understanding, we want to identify the commonalities and work on a harmonization from the different regulations in order to help understand and clarify the regulatory framework. And so we are going to set a standard for connected devices approval process. The third objective is to work on the data use agreement. So what are the rules around the use and disclosure of the data? We first need to understand the risks related to the use of such data, as well as the legal aspects with regard to tracking devices. And then we are going to identify mitigation actions and to describe the use disclosure for specific purposes. And then, so we propose to write an amendment of the conditions of carriage around the data use agreement. For the fourth objective, here we want to validate the set of standards and make sure that they fit for purpose. So that's why we've started defining pilots, and we invite you to join us if you would like to take part in this pilot project. So we are looking for stakeholders, and we are going to define different scopes, scenarios, to validate both the interactions we want with cargo as well as the approval of the devices. So the two key topics we are covering. So then for the pilots, so we are defining the roles and responsibilities, building the team, and we are following a stage gate process in order to run these pilots. So it will be starting next year, so 2021. The project timeline is as follows. So the project officially started mid of June, and we have been working on the interactivity characterization as well as the device certification. And we are going to submit 2 recommended practices as well as a policy paper by the end of December of this year. And for the data use agreement, so we plan to add this amendment to the conditions of carriage by the end of next year. And so we are also developing pilot projects, and we also address the COVID-19 aspect throughout this pilot project. Who takes part in this project? So the task force is composed of more than 50 participants, and we really want to make sure that they represent the whole supply chain. That's why we engage with shippers, freight forwarders, ground handlers, airlines, international and national organizations, aircraft manufacturers, device manufacturers, ULD manufacturers, and IT service providers. So if you want to know the latest updates about the project, feel free to check our website, and we will also promote the results of the project to the World Cargo Symposium in March 2021. And next year we'll start promoting the project by releasing news and articles and run advocacy campaign. So how to get involved? Feel free to contact us at interactivecargo@iata.org, and you can also check our webpage at iata.org interactive cargo. So with that, we will go ahead and maybe take some questions. So there's one question about the deck of slides. Yes, they will be available at the end of this presentation. So all the presentations from the guest speakers, as well as the video recording. So will all IATA airlines accept the device certification from IATA, or does the manufacturer still have to go through a certification process with each airline individually? So IATA won't deliver certifications, and it is still the responsibility of each airline to approve the use of devices. That's what EASA and Airbus will describe in the upcoming presentations. So stay with us, and you will learn more with Maite and Timo. So with that, we can move to the second part of this webinar with Paul Rodwell on how the use of connected devices will revolutionize the air cargo journey. So Paul, over to you.
Okay, I'd like to thank IATA and of course the sponsors for the opportunity to present this today. What I want to do is highlight some of the positive effects that IoT visibility solutions are having on the efficiency for this industry. The global inventory of IoT sensors runs to many billions, and it substantially exceeds the number of smartphones already out in the world. They're already widely used in the supply chain to deliver visibility and drive asset optimization. And we see the next phase of logistics development being closely aligned to what we as consumers experience every day with the use of our phones and the connectivity. Locations and traceability are substantially enhanced with the deployment of these solutions. So let's have a look at some of the levels that reflect both the complexity and visibility required. So I'll run through a few broad cross sections of current deployments and the benefits that they deliver. Then look at where the rapidly developing global communications networks are delivering greater value with complexity and autonomy. Here we have a highly effective and low-cost visibility of material across a broad spectrum of industry, and the use of cellular and Wi-Fi gateways with Bluetooth beacons in active use across many industries. It's a highly robust and scalable infrastructure with a virtual zone capability for effective real-time inventory management. And you can see examples which include factories and production facilities where location is critical, warehouses for stock levels, inventory control, trucks and trailers, and that all important load visibility in transit. And of course with aircraft for cargo, baggage and assets on those aircraft. Connected ULDs are providing real-time visibility of cargo and baggage movements. These enable airlines, handlers and customers to obtain essential location and condition information. Connected ULDs quickly identify disruptions where delays occur and for proactive intervention to mitigate incidents in the supply chain. Overall, they're powering digitally enabled services, delivering benefits to all the stakeholders in cargo and the chain of custody, removing processes with high manual input to improve handling efficiency, and it's a real enabler. Phones and apps are delivering edge visibility, passing inventory data to the cloud and the local users. The velocity of movement and exchanges in air cargo is a constant challenge for visibility, and there's a steep upswing in the use of real-time devices and recognition of how invaluable the visibility is. There are very few gaps or hiding places when deploying these types of devices. And when lives are at stake, it's vital that non-scheduled events are identified and recovery actions initiated. We, as a company, have many examples of saves that have resulted in the avoidance of delay and the inevitable impact on human lives. And additionally, the data being amassed from this real-time monitoring is powering optimization programs. Looking at the current wretched situation with COVID, we know there will be a massive challenges already highlighted by Sonia in the supply chain of time and temperature sensitive vaccines. Real-time visibility is going to play a substantial role in improving the efficiency and protection of those cargoes as increasingly coming to market. So looking at networks, LTE and NB-IoT are specifically designed for the IoT. LTE-M is well suited to the high velocity demands of transport and logistics, whereas NB-IoT is more for static situations. The coverage and roaming that is essential for globally deployed IoT devices is substantially improving all the time. Where not available, of course, there is the fallback to the 2G and 3G networks. The benefits of these license bands is the volume and the rate of data they handle. Networks in the unlicensed bands are effective for IoT where mobility and data rates are less important. Also, there are some very interesting developments with LoRa. The Bluetooth SIG, and that's the body that harmonizes and drives BLE, forecasts that over 4 billion Bluetooth devices will ship this year alone in 2020. They describe that Bluetooth technologies create connections that power innovation, establish new markets, and push the limits of wireless communications worldwide. Here we see it as the connectivity that binds. It creates guaranteed interoperability. It enables IoT devices to communicate on the edge and at local level. It's proven, it's constantly evolving, and a highly effective standard that delivers. we see it as an important contributor to the global standard for IoT devices in the supply chain. It's a given that connected consignments and pieces deliver location and sensor data autonomously. It's the basics. Where's my stuff? Diving deeper to information like, is it complete? Is it too hot? Is it cold? Or has it been damaged? And moving on from this to cloud-based use of the data for determining if it's running to schedule, and then onto data analysis to optimize the supply chain. Here again, the enormous pressure that will happen when COVID vaccines start to ship is a clear case for the unrivaled benefits that real-time visibility consistently delivers. So in the top bar, we see the evolving Cargo IQ message and status interchange structure. It's wholly reliant on clear input from all of the stakeholders along the chain. We've been involved in enabling connected assets and shipments to autonomously generate status and milestone and event messaging. And this includes the fully autonomous delivery of data from cargo warehouse to aircraft, including in-flight visibility and data, to cargo warehouse at destination, right up until the final location in the cold store. We're also working with the IATA Interactive team along the same lines, and I'll come on to a little bit more of that on following slides. Data sharing is readily enabled with API integration and the use of SDKs for smart devices on the edge. Here too are direct links to the Interactive Cargo team ontology developments. We also see this as a clear path to enabling AI and machine learning and look forward to the efficiency improvements that will flow to the direct benefit of the air cargo industry. We all know how beneficial technology is to our own productivity, efficiency, and our daily lives. So why don't we do the same thing for our assets? We, the consumer, are no different to assets in the supply chain. Location, itinerary, credentials, and history are common to everything. All these connected things, generating data and working in concert to automate processes, enhance operations, and ultimately squeeze the most value possible out of all involved assets and personnel. Empowering these assets with intelligence enables this level of connectivity. Today's rapidly developing use of AI in the consumer market can equally be applied to the logistics enterprise. So let's look beyond location and sensor tracking and think of scenarios and use cases only possible when the supply chain infrastructure is aware of the shipments moving through it. We see the use of these autonomous IoT sensors in the supply chain as the component to enable intelligent consignments to support the use of AI. It opens endless opportunities. This digital enablement delivers, and let's look at an example, a consignment with its shipping information embedded in sensors, such as unique ID, destination, mode, preferred routing, invoices, licenses, declarations. This links initially to perhaps preferred suppliers to identify and negotiate the optimum shipping terms. It can then make the arrangements to deliver into the transport network with the necessary clearances and protocols, and continues to monitor progress and adjusts and notifies for any deviation from the agreed terms. This sensor device also generates the native data block for the blockchain transactions. Throughout the shipment process, the consignment reports location and sensor data and raises alerts for any excursion. Also using contingency algorithms to adjust right through to the final delivery. On completion, it produces POD, fiscal and accounting processes, and any required shipment data and reports, such as stability and condition statements. It can also share data with all of the stakeholders and update inventories. The AI platform continues the machine learning process with each shipment, building the knowledge base and driving continual optimization and development program. So there, it's already happening. The way we work is changing. Through typing, we process around 40 words a minute. Through speech, 150 words a minute. Google estimate that within 3 years, we will be conducting most transactions through speech and image input. AI and bots will gradually remove a lot of today's mundane processes. It's exciting and transformative. We're entering the age of what we determine is cognitive logistics. So these cognitive logistics might seem like a significant challenge that can't be practically achieved in the short term. However, let's look more closely. We don't have to boil the ocean all at once. It's not just about tracking a shipment, it's about connecting that shipment to the supply chain in ways that deliver much more than coordinates and sensor values. It's empowering goods in the supply chain with the same tools and methodology that we as today's consumers use with our smart devices to both enhance and improve performance and purpose. But the important considerations still remain. So I want to look at some of the best practice and some guide to this IoT journey, starting with regulatory compliance. Just in this last week, I've seen an airline safety report where the pilots have reported significant radio interference from a device of some description being carried in the holds. The signal was strong enough to break through onto adjacent frequencies, and all of this occurred in flight, and it was just last week. I think it highlights the importance of the compliance standards for PEDs. There's no replacement for quality. Let's look at products and performance, focusing on real-world demonstrated results and not lab results and marketing hype. Our solutions mirror the global standards of the consumer market by using cellular and Bluetooth connectivity. So when you're assessing the many options out there, consider, with communications, are they equipped for reliable global roaming? Quality, is the vendor, the OEM or a reseller? Are they of suitable quality? Batteries, beware the claims of battery lives running for 10 years or more. And how often and effectively do the devices communicate? Can they be updated over the air? The all-important aviation approvals. If they're to be used in air cargo, they have to have the approval. Connectivity. Is there a fallback? Interoperability. We see the effectiveness of parent-child relationships. Are they important to you? A cloud platform. How robust, secure and accessible is it to the IoT data? APIs and SDKs, absolutely essential for integration and to drive developments like AI. So all these connected assets must ultimately communicate and operate in a cohesive way. At On Asset, we needed to identify the right technology to enable that ecosystem. As we had globally deployed fleet of cellular devices, we identified Bluetooth as the ideal solution for the digital enablement to piece level. It's an important element to deliver this interoperability. So when you're making your assessments, make sure the solution you're investing in now can grow with you and with the industry. Using Bluetooth in extremely dense environments presents many challenges, and we're a pioneer in successfully proving Bluetooth low energy devices can operate at the industrial scale using real equipment. We've extended the reader network and capability by deploying an SDK to empower users with local managed interoperability of Bluetooth devices. So overall, this cohesion delivers and can grow as it covers the digital enablement, Bluetooth roaming networks, regulatory compliance, the importance of security, messaging protocols, and equally device performance. So perhaps this managed interoperability framework is an aspect of integration that we could also look at with the interactive cargo team. So in closing, I just want to summarize that we're very pleased to be a part of this workshop, and we look forward to the developments that Sonia outlined at the beginning, taking us into next year. And I'd just like to hand over now to Sonia and thank her again for the opportunity to speak.
Thank you very much, Paul. We will go ahead and take some questions. So just a reminder, please be sure to type your question into the question box in the control panel. So we have a question from Christophe. So how is it possible to automate the handshakes between the stakeholders?
I think the process that we described there with the alignment with the Cargo IQ milestones is a starting point. It's something we've worked with a number of customers where we can layer visibility messages to coincide and align with that process. I don't know if that covers some of the question that's been asked.
Okay, thank you, Paul. We also have another question. So will there be guidelines or recommendations on IoT technologies to use, or will each stakeholder be on their own? So from IATA's perspective, so we don't push some technologies, and what we want to make sure of is that all the options are possible to get deployed. So that's why we work on the data elements, and so you may use any type of devices to get the data and push the data into the cloud and gain knowledge and insights from the analytics of such data.
I think if I just add there, Sonia, giving them a voice is the subject. Having the data available, having APIs, and the development working on the ontology that we've been looking at over the last few months, those are all enablers to linking those devices and the data that they carry with the stakeholders in that supply chain.
Yes, thank you very much, Paul. So now we are going to move to the third presenter. So I invite Maria to talk about ontologies for the Internet of Things. So an overview and lessons learned from success stories.
Thank you, Sonia, and thank you all for joining today. So I'm going to talk about the experience I have with some IoT ontologies and what we learn. And let me present myself before. I'm Maria Poveda, and I am an assistant professor at Polytechnic University of Madrid, and I develop my research within the ontology engineering group. That is a research lab within the UPM, and we have been working in ontologies and semantic technologies since 1995, so it's like 25 years from now. And more precisely within this group, I'm more oriented to all the ontology development, ontological methodologies and guidelines, ontology evaluation. And then I also have some experience developing ontologies in many domains. As you can see, IoT is one of them and one of Web of Things, but I also apply the techniques to other domains as video games, dataset, methodology, health, and so on. And what I want mostly you to know to get from this is that I'm a computer scientist. I work with semantic technologies, and I'm a bit outsider from your domain. So this is like a presentation from the semantic web perspective. And if you have any question about that field, I will be able to answer, but I'm not an expert in cargo or related domains. As you can see, we develop this research and ontologies within European or sometimes national projects and so on. And well, we also do some research, so I do some publications and organize research and innovation events. But what we are going to talk about is about the ontologies and how you can apply them. And then let's start with the definition of what is an ontology, or how we also say in the semantic web world, we talk mostly also about vocabularies, and I like this definition because if you see the URI where I can or URL where I take from is the W3C, that is the web consortium, which is the organization that provides the standards for the web. If something works in the web is in the same way for all the browsers, for example, is because the W3C write the specification, then they say a standard / semantic web / ontology, and the definitions say vocabularies define the concepts, relationships used to describe or represent an area of concern. So this shows from the beginning that we will talk about vocabularies and ontologies in the same way in this domain, okay? But there are more definitions of ontologies and more formal ones, and some things that we have to take into account when we talk about vocabularies or ontologies here is that we refer to formal and machine processable artifacts. So there are not only the definitions or the ideas which are presented, but this definition has to be read and processed by machines. And then having these artifacts that are formal and are written in machine processable languages, we can have many benefits. For example, the first one, as I said, is sharing the semantics, because they are not like that fixed, rigid data model for one specific technology, but we will be able also to provide the semantics on the terms that we are going to share. More precisely, in the technologies we use, it is based in description logics. So I can define one concept based on the definition of other concepts in a formal way, okay? So the other big benefit that are always shared with ontologies is interoperability. So we don't have ad hoc models, but we can have a common models to share data between devices, services, or systems that are handling data in different languages. For example, I can share systems that has data in Spanish with others that have data in English, and many others. Also different granularities, like countries or cities or neighborhood, different formats and schemas. Sorry. So we also help for the disambiguation and the reasoning. So the disambiguation is because we are going to type everything that is in our data model, so it will be there will be no ambiguation. And also we can apply reasoning because we can infer new knowledge from the knowledge that we annotate with the ontologies. And of course, the big benefit is that we will be able to reuse someone else's or our ontologies. So maybe you know about this ontology index that is linked open vocabularies. And then if we go and look for IoT ontologies, we already found some heterogeneity in the ontologies that we can find. But we thought, okay, we are going to use ontologies to end with the heterogeneity, to finish with that. But then we find also heterogeneity in the ontology. So it is clear that we will have to have some criteria to select which ontologies to reuse. So let me talk about the standard ontologies that are available for IoT projects. The first one is the Semantic Sensor Network ontology that was developed within the W3C, and there was a first version in 2011 that contained 10 modules, but only one file. So that was like a monolithic approach. And I want to mention that because that is important in the next developments. So it was based in the stimulus sensor observation pattern, in which the link from the measurement that was observed and the real world entity the real world entity that the measure refers to was the stimulus. Okay, that stimulus observation was the link to the real world. But if you study the ontology, you will see that there was a shortcut introduced so that the ontology can link from the observation directly to the property. Okay, the properties there are like temperature, luminance, and so on. But at the origin, it was based on this pattern, a stimulus sensor observation, to make the path. And if you have a look at this ontology, you have observed that the sensors are not devices. Well, there was device in the first version, but they removed it in the second. And the sensor was not always a device, because they consider a sensor also agents and could be, for example, persons. So in the second version, the main thing is that they added the actuators, because there were no way to represent something that can affect the temperature, for example. They removed the device, and the important thing is that they made a modularization. So they split this big file in different files, so each project can choose the level of complexity that you want and also the features that you want to reuse, and you don't need to reuse the whole ontology. The other ontology I wanted to talk to you about is the SAREF, that is an initiative from the European Telecommunication Standards Institute that at the beginning was oriented to create interoperability between appliances in houses. But then it evolved to applications in every domain. As you can see, from 2017, there are SAREF extensions for energy, environment, building, smart cities, industry and manufacturing, and so on. So this is the core model, of SAREF. As you can see, main entities are similar to SSN, that are devices. The observation here are called measurements. There are the properties, unit of measurement, and the services that the devices are defined for. As I said, SAREF is a core ontology that is by design aligned with 1M2M based ontology for representing the services. And on top of this SAREF core ontology, there are several developments to define the specific devices, properties, and any other entity that might be needed in different domains. Okay, and for example, in one use case for a smart city, we could be reusing different extensions. For example, if there is a concert, we can use the building extensions for getting information from the hospital or sending notification in case that is needed. We can use the wearables to see how many people is inside. Also, we can use the automotive one to let the taxi company to take another route because the other one is there is a traffic jam in another street, and so on. So in this case, you see that the approach is more modular, but you can combine them. Also, you can see in this slide how SAREF or some of the extensions reuses W3C standard ontologies like SSN and SOSA, old time, the organization ontology, and other well-known ontologies. So here I just wanted to show you one example of this reuse. For example, in the case of the SAREF for smart cities ontology. Okay, so you can see in yellow is the SAREF core ontology, and it is extended with those concepts in orange that we need for the SAREF for city domain, and the white boxes are the links to the standard or well-known ontologies that we are reusing for this extension. Well, I will go quickly through this example that is a context-aware system for smart irrigation, because it is the same case we were reusing. In this case, the SSN ontology is the green part, but also combined with SAREF. So here we are reusing both IoT ontologies after analyzing here which one or both cover our requirements. Another similar example, well, in this case, apart from the reuse and extension, I just wanted to mention that from the Vicinity project, we needed to represent the Web of Things. And at that time, the Web of Things working group from the W3C was not, didn't hand in the Web of Things ontology. In this case, we use the project output to feed the W3C first model and then involve that to make it an standard. So in this case, we were reusing standards and also feeding in other standards. Just to wrap up, because I'm finishing, the message is to take home are that modularize your ontologies. You see that in the SSN, first they have a big monolithic one, and in the second version, they rapidly split it in several modules to make it easier to reuse. Reuse, but not only on ontologies, reuse also the ontology languages, because the logic are already there, don't reinvent the wheel there. And also because if you reuse the language, in this case from the W3C, the web ontology language, you can also reuse all the methodologies and the technology that is ready to work with these languages. And also, of course, to reuse other ontologies. I have been looking for cargo in link open vocabularies, and also only found general terms from DBpedia. That is not a specific cargo ontology. And finally, if you develop your ontology because there is no one that you can reuse, if your project allows it, I will share it with the rest of the community so that others can also implement on top of your ontology. And that has been all from my side. Thank you very much.
Thank you very much, Maria. So we have a few questions on the topic. So it starts from
I'm going to see.
So, who uses the semantic sensor ontology? Who are the users of this ontology?
So, well, one important thing regarding this question in general is that we developed ontologies and then we publish them online. So there might be many people using them, but we don't get like notifications. We only know if someone asks us. But the sensor network ontology is used, for example, we have in Vicinity, we use it for making, imagine I have buildings and cars and things, and we create IoT ecosystems. So we use that for tagging the things, the sensors that belong to a building and so on. And we also tag that to map with the Web of Things ontologies. In the Web of Things ontologies, you can say where someone can find your data on the web for a specific property. And I wanted to mention that because it was related to Paul comments on the subscribe. So with the Web of Things, you can make this link from the IoT to the subscribe to this event. Then you tell someone else where to find that information. So when you tell someone else where to find that information, you can also say and how to interpret that information. So those mappings, we were using like SSN and many other ontologies to say in Vicinity, you can find here some information and you have to read it with this ontology.
Okay, thank you very much, Maria. We have another question, which is which sectors are the most advanced in the use of IoT ontologies?
I'm not sure because I don't know about all the domains, but I have a feeling because of the papers I read or the events I attend that in the householding, in the houses, they have more advances, like the fridge connecting to the dishwasher and then a sensor for opening a door, and then you know if there is people inside and so on.
Okay, thank you. And we have one last question, which is, how can we apply ontologies in tracking shipments moving between different stakeholders?
So yeah, I think that the whole system will be quite complex because you also need to deal with rights, with policies to know who can access which data, because I don't think you want a centralized approach. So this case is very similar to the vicinity because they create neighborhoods and ecosystems. Then you use the Web of Things, another ontology, to say which the vicinity ontology to say with whom you want to share which data. Like these people have access to this data. Then you select your stakeholders there. Then these stakeholders will be able to access the data with these other mappings that I told you before. Like I say with whom I want to share, and I also share with the platform where is my data. And the platform only offers to each one the data they have access to. And then you say with whom, which data, and also how to interpret the data. So
Okay,
I will include because we published recently a book from Vicinity with all the platform, and I will include that in the slides because it's quite similar to that.
And to complement your answer, so for air cargo, so we have the one record ontology. So our data model covers these mechanisms about who I'm going to share the data with, and also the security aspects. So feel free to check out our one record website on the IATA website. So now we're going to move to our next presenter. So Liam Ford from Ericsson on the importance of a common data model. Oops, sorry. Sharing my screen. Sorry. So thank you to Liam to speak today about the importance of a common data model for the Internet of Things in logistics. So Liam, over to you.
Great, thanks, Sonia. So as mentioned, I'm going to talk about the importance of a common data model for IoT in logistics. My name's Liam Ford, and I'm a solution architect at Ericsson One. Ericsson One is an internal accelerator, and yes, we get to work with some really cool projects. So projects like controlling platforms to control drones out of sight. A project I worked on a little bit earlier was connected logistics. And in connected logistics, we worked with a lot of the early ideas of the Internet of Logistics and One Record, and that was a great opportunity. And more recently, I'm working on a project called Critical Asset Tracking, and more focusing, taking the ideas from connected logistics and focusing on Ericsson's 5G and IoT strategy. That's not me, by the way, as you can see, but I like to play with cool things. So we look at IoT today. This is, last year Gartner said that in 2020 we'd have 6 billion IoT connections. I don't know if COVID's impacted that positively or negatively, but it's where we are today, and we're obviously expecting huge growth in this area. We're only still in the infancy of IoT. Interestingly enough, if we look at transportation and logistics, it's at the sort of lower end of the adoption of IoT, and I believe that's not through need or value. I mean, if you think of IoT, I think of logistics as one of the great use cases for it, but I think it's more a reflection of the complexity when it comes to the landscape of logistics and transportation. So if we look into the value we want to get from IoT in logistics, the three main use cases that often come up are track and trace, condition monitoring, and automated event handling. And it's, people think of track and trace first to know where their goods are, and that's important use case. But it's a use case we don't see the biggest value to enterprise at. With the biggest value we see is in automation. If we can share the value of IoT across the different participants in the logistics chain, we're going to unlock lots of value for a lot of these companies, and that's in the benefit of the shipper, but it's also in the benefit of the receiver. And if we want to, so it's in our interest to make sure that all the parties in between can use the benefit of IoT and automation. So if we dive into maybe a specific use case of this and condition monitoring and automation, and here we've got some smart robot trucks carrying containers, and if we look at what the conversation they might have, and it might start with a container X. I've arrived at receiving location Y at a specific time, and here's my digital twin address. And they might get a response from another machine to say, thank you, container X, please park in bay 1, and ladder A is ready to start your loading. Very polite machines, which I like to imagine. Another sort of example of this might be in condition monitoring, where you have, this is container X, I'm reporting a temperature of 32 degrees Celsius, which is outside the transport agreement policy, and this occurred at this specific location, and I've notified these different parties. And again, you might get another empathetic robot saying, thanks, that's concerning container X, I've created a report and sent a maintenance team to urgently attend. Please park in bay 9 for further instructions. So what I wanted to demonstrate here with this conversation is this is happening between two different machines from most likely two different enterprises or organizations. They're going to need to communicate. They're communicating they're not dumb robots here. They're not communicating, I'm at position XY, I'm at position XY, I'm at position XY. They're communicating a contextual information to say, I'm in your receiving location. And similarly, they're not reporting a temperature, I'm 20 degrees, I'm 20 degrees, like a parrot. They're going to be communicating, I've actually exceeded my transport agreement policy, and therefore you need to know about this, and so do different other parties that need to know about this. So how is this going to work if we go into the architecture of IoT? So this is a typical IoT sort of layer cake with some slight tweaks for the logistics and for this presentation. You start at the bottom with your things. You've got your containers, you've got your ULDs, packages and pallets in the billions. You've got the device manufacturers in the hundreds, possibly thousands. You've got device types definitely in the thousands. And you're going to have standardization efforts. There's many, lightweight M2M, one data model, one M2M in play. And also a lot of other challenges when it comes to battery, cost, trust, and quality of the sensors. Go up in the stack, you've got your connectivity layers, and when it comes to logistics, we have that challenge of it's not just in a controlled environment like in the other market segments that you might have IoT. You want to be on a macro network. So you need your cellular-based technology, and there's been big advancements in that with rolling out IoT-specific protocols like CAT or network technologies such as CAT-M, narrowband IoT, and what 5G is then going to bring with those. And these technologies will allow these connected machines to roam and to get coverage globally. And then going up, you've got the device and connectivity management, which are going to be managing the life cycle of billions of connections and devices. And their key concerns is going to be security and transformation, because we're going to be coming from the edge. And from the edge, you may have constrained devices, and they may be talking very unsemantic type data models. And we will need probably to transform that into a more semantic type data model. And then if we look at going up, there's what we call the contextual layer, and this is sometimes called an abstraction layer. And this is where we see that filtering out the noise and providing meaning to the data, and to share that information with interested parties. And obviously this layer is going to be business rules driven. So this is the main layer that we see connecting with the Internet of Logistics and One Record, with all those different participants. This is the layer. We're not going to want to flood and share the data in an event-driven manner of just a sensor reading every 1 minute. There may be use cases for that, but that's not going to be the majority. And then above that, you've got the Internet of Logistics. It's going to come into the back-end applications, and there we're going to drive automation in processes. So coming back, this contextual layer is what I referred to before with that conversation. And obviously, if you're going to have that sort of contextual layer and that sharing information, we need a common data model. And that's not a problem that is being recognized by me or by Ericsson. This is a very commonly termed problem across the whole industry of IoT. It's one of the biggest impediments to IoT adoption on a broad scale. And there is another impediment to IoT adoption on a broad scale, especially for logistics, is the competing one data model initiatives out there, which there are several. So, I mean, at the moment, in a lot of industrialized commercial type applications out there, we've got less semantic data models out there. In Ericsson, we work a lot with lightweight M2M, and that is out there on our sort of industrialized products. And then if you go to more like local area networks, like home networks or anything like that, then you've got some other standards out there that are sort of industrialized. And then you've got the more semantic type ontologies that Maria was referring to before in a previous presentation. And you know, there's at least an acknowledgement out there that, you know, we need to move towards these semantic type ontologies. We need the interoperability. And, you know, we have one data model that's an initiative out there. Unfortunately, that's not an ontology-based semantic data model, but they do call it semantic data format. But then we have one M2M, which is ontology-driven, and we also have the Web of Things. And this is hopefully the direction we're moving in for commercial applications. So at Ericsson, we think this is a good time for logistics and IoT. And the reason why we think that is costs of devices are reducing, performance of the device are improving, and that is predominantly driven also by the connectivity improving. I mean, with narrowband IT and Cat-M, and now with 5G, we're having technologies out there that are driven towards IoT devices. So it's enabling cheaper devices to be built. It's also enabling devices to have better performance and use their battery more efficiently. We also have cellular position improving, and this is important because if we've got using cellular-based devices, if we can avoid having to put GPS components into these devices which take readings, then we're again going to save battery and we're going to get better performance out of IoT devices. And of course, we've got AI and machine learning, which is helping us in all the different areas of IoT and ecosystems of IoT innovators. So that was what I wanted to present today. I thank IATA and Sonia for the opportunity to present. And I'll hand back to Sonia, and if there's any questions.
Thank you very much, William. So we have one question. Sorry. What are the outcomes of Ericsson's IoT architecture?
Well, that's a very broad question. What are the outcomes of Ericsson's IoT architecture? Ericsson is been quite successful right now with its 5G rollouts. So that is also obviously a very important part of the architecture. I think we recently signed our 100th 5G contract. So that is extremely important to get the network coverage out there and the ability to get the roaming out there between on those networks. In terms of, we offer a device connectivity platform and device management platform that is industrialized and being sold out there, and that's connecting billions of devices, or millions of devices probably, I'm not sure the numbers. We, as I mentioned before, I'm working in the more accelerator area where we're trying to innovate, and that's where we're working on that sort of contextual layer and sharing that. I hope that answered the question.
Okay, thank you very much. We have a question from Paul Rodwell. So is 5G suitable for global roaming devices today? If not, when?
That's a good question as well. I mean, 5G is being rolled out now, so it's going to be interesting to see what that brings to the 4G sort of technologies of narrowband IoT and Cat-M, to see how that improves. I mean, with 5G, it's going to be increase the performance of the network, allow many more connections, and Cat-M is obviously going to be behind that. So that's the roaming sort of, technology out there. It's based on the LTE technology. It's the Cat-M LTM is available now for roaming, and they're definitely looking at narrowband IoT and its roaming capabilities as well, because that's not based on LTE, therefore it has some challenges with the roaming, but they're looking at how to make agreements and new standardization for that.
Okay, thank you very much, Liam. And so Rudy also says that he thanks you for your excellent presentation. So thank you very much, and I will move to the next presenter. Maite Iniguez Yarza from the European Aviation Safety Agency. On allowing portable electronic devices operation in an aircraft, focusing on the regulatory framework. So Maite, so over to you.
Hello, Sonia. Thanks a lot for inviting EASA to this presentation. And I would like to, my presentation is about it's an introduction to the regulatory framework for the allowance of the PED operation in an airplane. To start with, the portable electronic device, or PED, in the regulation is defined as any kind of electronic device that is brought on board an aircraft, like a tablet, a laptop, a smartphone, any IoT device. Regarding the regulation, it has been evolving in the last years. In the past, there were restrictions in the use of PEDs on board aircraft, but in 2013, the use of the PEDs was already allowed for almost the whole flight duration, but always in airplane mode, so not transmitting. But from 2014, the operational regulation has been updated to allow the use of PEDs throughout the flight, regardless if they are transmitting or not. But it's up to each airline to allow the use of the PEDs or not. And in order to do this, the airlines will have to go through an assessment process, ensuring that the aircraft are not affected in any way by the transmission of signals from the PEDs. What is exactly the European regulatory framework? In the European regulation 965/2012 on air operations, there is one specific requirement, that is the Guardian MPA 140, that states that is the operator's responsibility to authorize the use of PEDs on board an aircraft, after having ensured that there is no impact on the safe operation of the aircraft. This requirement is complemented by some acceptable means of compliance and guidance material in the Part CAT for commercial transport operation. This is the list in the slide of all the AMCs and GEMs that have been published, and all these documents can be found in the EASA website. But why this assessment is needed to be performed by the operators before allowing the use of the PEDs in the plane. What are the risks that the PED can pose in the aircraft? Basically, it's about the radio frequency energy that is radiated by the portable electronic devices that may potentially be a source of interference for the aircraft systems. First, it can induce unwanted responses by direct coupling into the aircraft electronics equipment and its wiring. This is called backdoor coupling in the EMC world. And this is always caused by the intended emissions of the PEDs. In this way, a malfunction of the aircraft electronic system can be created because of this electromagnetic coupling that can create major hazardous or even catastrophic failure conditions in the plane. But also, any PED, even when it's not intentionally transmitting, is emitting some kind of spurious emissions due to the internal clocks and the switching of the electronics inside it. If these emissions fall in the frequency range of the communication and navigation systems of the plane, then there are possible disturbances in the communications, in these systems, and this can lead to catastrophic effects in critical phases of flight, in particular for low visibility approach operation. This is called the front door coupling. Now I would like to make, until now we have focused on what is the operational requirement, but I think it's very interesting for operators that in the world of certification there is some requirements for the PED tolerance also. But because the PEDs are not part of the aircraft configuration, there are no specific certification requirements addressing them directly. However, the aircraft manufacturer may want to certify an aircraft as PED tolerant if the use of the PED is foreseen. For example, when an in-flight entertainment system with wireless capabilities is being installed. In this case, the PED tolerant certification can be used by the operators to perform their assessment to allow the use of the PEDs on board. In the world of certification, the requirements for the acceptable means of compliance for demonstrating an aircraft as PED tolerant are in the certification memorandum ES003, that again is published in the ASA website. Through the certification, the aircraft can be demonstrated to be PED tolerant for all kinds of PEDs, with the PEDs in any place of the plane, or it could be restricted to certain wireless technologies and certain areas where the PEDs can be. This depends on what the aircraft manufacturer chooses to demonstrate. But all this information can be used by the operator to perform this assessment on the PED use that is required by the operational rules. Then the operator may need to restrict the PED operation depending on to what extent the PED tolerance has been demonstrated in the certification. Also, there may be other reasons for the operator to restrict the use of the PEDs as a result of operational or local regulatory requirements that has nothing to do with the electromagnetic compatibility demonstration. If we want I would like only to mention a little bit more about the specific case of the cargo tracking devices that appear also in the operational regulation with some alternative means of compliance. A cargo tracking device in the EASA regulation is defined as any kind of PED attached to or included in air freight. The EASA does neither certify nor approve cargo tracking devices as any other PED, because there are no requirements to obtain a certificate from EASA to operate these devices. In the past, EASA was issuing some non-technical objection letters for cargo tracking devices, but this service has been stopped in 2019. And in the EMC1 of the CAD-GEN MPA 140, there is a paragraph that is dedicated to an alternative way to demonstrate EMI compatibility for the specific case of the cargo tracking devices. And as for any other PED, the operators remain responsible to authorize the use of the cargo tracking devices on board the aircraft. In any case, in the certification world or in the operational world, the acceptable means of compliance to allow the use of the PEDs or to demonstrate the aircraft as PED tolerant, that is the same, are totally identical. To demonstrate the backdoor coupling, to make a backdoor coupling assessment, both the certification memo that I mentioned before and the operational requirement refer to the Eurocae ED 239, Section 3, or the Eurocae ED 130A, and for the front door coupling to this, the same documents, another section that is dedicated for that. So the process is always the same in the certification world or in the operator world. I only wanted to note you that for the front door coupling, the operational rules only require to perform that assessment if the PED is going to be allowed to be used in low visibility approach operation. If that's not the case, so the PEDs are going to be required to be switched off during critical phases of flight, then the front door coupling is not necessary to be assessed. But what comes in these documents? These documents focus on the electromagnetic demonstration of the PED tolerance in an aircraft. For the backdoor coupling, basically there are three ways to demonstrate this EMI compatibility. One is relying on the HIRS certification of the aircraft. If an aircraft has been HIRS certified, it's basically PED tolerant for backdoor coupling. There is still needed to a small step to assess the cockpit voice recorder and the flight data recorder, because this tool is not taken for granted only with the certification that their qualification levels for electromagnetic susceptibility are enough to ensure the PED tolerance, but it's not a very difficult exercise. It's only focusing these two pieces of equipment. If the aircraft is not HIRS certified and there is no data about it, or is only partially certified because it's an old aircraft that has been subjected to different modifications in the time, then it is needed to perform an aircraft EMI ground test as defined in the Eurocae documentation for all the systems with catastrophic, hazardous, and major failure conditions. That is basically what has always been done, I think, for the operators and to demonstrate the safe use of the PEDs on board. But in the case, the PEDs that are going to be allowed are only transmitting very low power emissions that is defined in all these standards as an EIRP lower than 100 milliwatts, then it is considered that the risk of backdoor interferences can be neglected, and then nothing is necessary to be demonstrated. For the front door coupling, basically this demonstration is always based in the interference path loss measurements. How to do this kind of measurement in the plane is described again in the ED 138 or in the RTC ADO 363, that is basically the same document. And basically it consists in measuring the amount of energy loss traveling from the PED inside the plane to the aircraft radio receivers. And then comparing the data that the measurement that is made with some thresholds that are defined in these Eurocae and RTCA documents. For the specific case of a CPD, that is a control PED, that is any kind of PED that is subject to the administrative control by the operator, an alternative means of compliance, instead of making these IPL measurements, is to perform a qualification of the PED to the for electromagnetic emissions to the Eurocae ED 14E or later revision, section 21. Category H if the PED is intended to be operated in an area not accessible during the flight, or if it's going to be in an area that is accessible, it will be another category, it will be category M. And all this is explained and detailed in the certification memorandum and in the AMCs of the operational rules. Another aspect that the operational rules highlight about the use of the PEDs, about the allowance of the PEDs on board, is about the lithium battery. The AMC1 CAD-GEN MPA 140 requires for the lithium batteries in the CPDs and in the cargo tracking devices some minimum qualification standards. First, the United Nations Transportation Regulation on the recommendations on the transport of dangerous goods, and one of the standards that are listed here that basically are standards containing lithium battery qualification requirements depending on the battery size. Also, the capacity of the batteries in any PED that can be carried on board is limited by the ICAO document 9284 technical instructions for the safe transport of dangerous goods by air. That is limiting the amount of lithium in the battery of a PED to 2 grams for lithium metal, 100 watts per hour for lithium ion, up to 160 watts per hour under operation approval. In the case, these requirements in any case are not the ones for certification, because when a system that is installed in the plane is certified and contains a lithium battery, the requirements for these lithium batteries are much more restrictive than the ones for the PEDs. So it's not compatible and it's totally different. And basically, this is a summary of all the regulatory framework for the use of PEDs on board a plane. Thanks a lot for your attention.
Thank you very much, Maite. So we have some questions from the audience. So there's one question. So, are using PEDs on an aircraft now considered relatively safe? And if so, why do rules using? But I think the sentence is not complete. So are using PEDs on an aircraft now considered relatively safe?
Well, basically, with the last amendment of the EuroCAM and LPCA documents for the PED tolerance assessment, it has been determined that the emissions of all the wireless technologies that exist in the world and are foreseen in the close future can fall within the envelope of the HERE certification of the aircraft. So if in a modern aircraft that has been HERE certified, that in Europe, in accordance with the ASA rules, it would be an aircraft certified after 1987, we could say that it's relatively safe because the HERE certification of that aircraft is already making the aircraft PED tolerant. So that means that in principle there should not be any major hazardous or catastrophic failure condition due to the PEDs. Always with the exception of the speaking about the backdoor coupling, because the front door coupling is very specific for the case of the low visibility approach operation of the low ones of the PED in that particular phase of flight. But for the aircraft that are old, we are still requiring to perform some EMI assessment in detail because the qualification of the systems is not known. So,
okay, thank you. And maybe one last question, as we are running out of time. With EASA not certifying nor approving the CTD, does it mean that it is up to the airlines to allow these devices to be on board or not?
Yes, it is up to the airline to allow the device to be on board or not, exactly as any other kind of PED. So the airline, the operator needs to follow the guidelines of this requirement that I mentioned at the beginning of my presentation, that basically puts all the responsibility on the operator. The requirement reads, the operator shall not permit any person to use a portable electronic device on board an aircraft that could adversely affect the performance of the aircraft systems and equipment, and shall take all reasonable measures to prevent such use for absolutely any kind of PED, including the cargo tracking devices.
Okay, thank you very much, Maite.
Thank you.
So with that, we'll move to the next presenter. So with Timo Stadler from Airbus. So on what progress has been made in the certification of portable electronic devices on board aircraft. So Timo, over to you.
Yeah, thank you. I hope everybody can see me. We have a little bit of technical issues here. I'm connected by phone, so I really can't see what you see, and I have to rely on Sonia to switch the correct pages. Okay, so I'm Timo Stadler. I'm from Airbus. I'm the EMC engineer, or one of the EMC engineers of Airbus. And you will see that my presentation, the presentation of Maite you heard before, are quite similar in some ways. This is Maite and I. We have both been in the working groups and special committees of RTCA and EuroK to change the portable electronic device guidance material. But I hope that my presentation is a little bit more on the engineering side, as I'm an engineer and not part of an authority. Okay, let's go to page 2, please. In the same way as Maite, I also start with a little bit of definition and background. As you can see here, I have made a slide of portable electronic devices and what I mean with aircraft. With aircraft, it's simple. It's large transport category aircraft, maybe even rotorcraft, but definitely not general aviation. General aviation has completely different rules. And when I talk about portable electronic devices, I actually mean anything on the aircraft that is not certified, that is brought on the aircraft, used on the aircraft by passenger and crew, or by the cargo. So cargo tracking devices are a subpart of portable electronic devices. And I can give you that in the same way as Maite already said. There's 2 ways to use cargo tracking devices on an aircraft. First, you could just evaluate the aircraft for EMC. So in the same way as treating all other portable electronic devices, you would then call the aircraft a PET-tolerant device, or you can treat the cargo tracking device. Let's go to page 3, please. Okay, I will not define what a tracking device is because I learned today that you guys know that much better than I do. But I can tell you what is not a cargo tracking devices. What's not a PED and what is not a PED is everything that is installed, fixed, or certified on the aircraft. Yes, so let's go. I will be very fast. Let's go to page 4, please. I will be very fast on the first 7 slides because I need a lot of time on the 8th slide. Okay, I think you see now the background coupling. And it is the same picture we also saw on Maite's presentation. And the only thing I want to take from this is that there are 2 aspects to coupling of an equipment on an aircraft, and that's backdoor coupling and front door coupling. So the blue coupling and the red coupling, while coupling to harnesses and wires is, from technical point of view, not relevant. Please go to slide number 5. Another background, HIRF. So high intensity radiated field is normally something that does not affect the operator at all, because this is something which is negotiated between the authorities and the aircraft manufacturer. It is part of the type certification and then later of changes to the aircraft, changes to type certification order or STC if done. HIRF stands for high intensity radiated field, and it is an environment that is created by any electromagnetic field that can be expected where the aircraft is. So it's maybe radio towers, radars, and so on. There's different HIRF environments defined in over time. So today there is the EASA FAA HIRF regulations, which are identical or nearly identical. And in the past, there was the Joint Aviation Administration HIRF special conditions and the FAA HIRF special conditions, which are not the same. I'll tell you that because we have to come back to these words a little later in slide 8. Yes. By the way, just to make that sure, even before the 1980s, before the HIRF environment was formalized, aircraft were not unsafe, and they still are not unsafe, because at that time those aircraft were mainly mechanical. At least the critical systems were mechanical, and then later when we installed electronic systems on pre-1980s aircraft type, we considered, of course, the HIRF environment And in this case, I can only speak for Airbus because I have no idea what others are doing. Okay, let's go also very quick through the history of PET tolerance standards for aviation. Oh, no, I clicked to the next slide without saying it. I need to go to slide number 6, please. Let's have a look at the history a little bit. So it started actually in 1963 with the first evaluation of that. Then you probably remember that you had to switch off your portable electronic devices for a long time. Then in 2006, we get the first reasonable PET tolerance guidance material, which allowed us to install the first mobile communication base station on board of an A318, I think, which was Air France at that time. So that was the first time you were actually allowed to use a mobile phone on an aircraft, or specific aircraft which had undergone a lot of specific tests. In 2016, the results of a lot of those tests have been evaluated, and the working groups of RTCA and EuroK came to the conclusion that slight relaxation of the standards is possible, is reasonable, and that basically the backdoor aspect of a PED is covered by the so-called HERF environment. And since then, we have harmonized standards. So the DO307A is identical to the EuroK ED239, and the 363 of RTCA is identical to the ED130A, which is good news. And also on the next slide, you will see that these last standards actually also include something about cargo tracking devices. Okay, so I have rushed very fast now, so I would like to go to page 8 now, please, which is how to analyze if aircraft is PET tolerant. And you have seen a similar slide, I think, with Maite. It's basically the same. We always just look from different sides. And by the way, if I contradict Maite from EASA, she's right because EASA is always right. So let's start. Let's start with the right-hand side. So if I have to analyze an aircraft for PET tolerance, so think about you have a cargo tracking device. You want to transport that cargo tracking device on your fleet. You are an operator. You want to transport the cargo tracking devices on your fleet. There's two options, as I said. One is to analyze the aircraft. The other was to analyze the cargo tracking device. We'll come to that later. Let's go first to the aircraft. So what you do is you have to analyze two aspects. One is the backdoor aspect. One is the front door aspect. And for the backdoor aspect, what you do is you check if you have a HERF certification at type certification of the aircraft. And that means you either have to have EASA FAA HERF regulations or JAA HERF special conditions. And the best thing to do is just ask your aircraft manufacturer, and the aircraft manufacturer should give you this information if you tell them why you need it. The other way would be to ask for to look into the TCDS, which is the type certification data sheet, which is public information available at EASA and FAA websites. If that, and by the way, it is not the secret that since A320, every aircraft has a HERF certification as per JAA HERF special conditions or EASA FAA HERF regulations. So we're talking here, at least from my point of view, from A320 on. So yeah. The other possibility would be to perform a backdoor test as per ED138, but I have to say that I cannot really recommend that. It is really a difficult test to perform. But it has been done, and it has been successfully done as well. The other aspect we have to see is the front door aspect. You remember the page 4, where I showed front door and back door coupling. So the front door aspect is only demonstrated by test, or can only be demonstrated by test or a similarity analysis. And if you normally buy an aircraft today, this test will have been performed by the manufacturer already. because we only performed it once per type. And then if we do really big changes, like putting another door in it, then we'll have to maybe perform it another time or do an analysis. So what you do is you ask again your manufacturer, is the front door aspect, has the front door aspect been tested as per these standards? Now, if we are talking about cargo tracking, so I assume people in the call will own some freighters. And for freighters, I know that these are freighter conversions, and Airbus has not performed front door testing on freighters. So if you own a freighter, you have to perform such a front door test yourself. You refer to DO 307A section 4 for this. The test itself is not very difficult. However, I would recommend to involve experienced external experts for this, just to reduce the effort. Because if you just look into the 307, you might think you will need 2 weeks for testing, but this can be done faster, much faster. And from my point of view, if you have overnight stops, this can be done in 2 night shifts. And by the way, if you ask for quotes, please include your aircraft manufacturer, maybe Airbus as well, because that would get me out from my desk to some interesting task. Okay, now if you have done front door and back door aspects, your aircraft is, and successfully, your aircraft is pet tolerant. It also means you have to check a little bit on instruction for continued airworthiness. And as I think Maite already pointed out, this is given in section 5 of these standards, and it's not very much to do. It's simple, but still has to be done. Okay, that was the first part. Now let's go to slide 9 and have a look how Eurokey RTCA looked at tracking devices. And so if you want to check the tracking devices, as per these standards, you would have to perform tests only on the tracking device. And the first test would be of spurious emissions, and they should be below category M or H, depending on where you want to transport it, of section 21 of the DO 160. If you want to be on the safe side, just test H. You also have to check the intentional transmission. Intentional transmission is the signals which the device, the IoT signal the device is emitting, like Bluetooth or Wi-Fi or 3G, 4G, 5G. And this must be either below 100 milliwatt EIRP, or it must be switched off in flight by 2 independent means. Additionally, the standards wants the device only to have a very small duty cycle of emissions. But to be clear, the duty cycle is only meant to be attached is only meant for equipment that is switched off by independent means. If you are below 100 milliwatt with the equipment, the duty cycle part is not relevant. This becomes clear if you read the complete standard. If you only look at paragraph 3.7, it's maybe not that clear. The idea behind all this is that the tracking device manufacturer prepares a kind of a documentation package, and then the operator can review that and allow the tracking device on board. Now I put this sentence below it, see also advisory material of local authorities, because you have to. Because unfortunately, while the PET tolerance assessment of aircraft is quite standardized around the world, and the standards I mentioned from Eurokey RTCA are recognized by most authorities, the standard for the tracking device is a little different everywhere. And I tried to just overlay the requirements by Eurokey, the requirements by EASA, and the requirements by FAA. And then you are here. Actually, I have to say the FAA mostly recognizes the Eurokey RTCA standard, while unfortunately the EASA does not. But okay, this is the overlay of all the three. And you can see that, again, the spurious emissions must be below category H. And the internal transmissions must be below 100 milliwatt EIRP. And the independent switch off is not really an option anymore, because the at EASA, the independent switch off is linked to HERF certification of the aircraft. But if you have a HERF certification of the aircraft, then you basically are easier off with just a PET tolerance demonstration of the aircraft. Okay, so then if I have a HERF certified aircraft, I would not try to go the way with the evaluation of the tracking devices. Then it's easier to do the other one. Okay, so this is, I think, what you can see here now on this page is what I think can be transported on any aircraft from EMC point of view. Again, batteries and everything is out of my scope. Can be inside every aircraft. And then again, please look at the advisory materials of your local authorities. So maybe if you're located outside the EASA FAA jurisdiction, you may have still different rules. And okay, I have to hurry up. Please go to page 11. Here I have just put the guidance material. Again, you can see the two standards up here. Material from the FAA, which is, I think the most important one is the upper one, AC 91 and so on. And yes, you can also see the EASA part cut and so on, which we've heard about. I don't think we need to go very long over this. Let's come to the summary on page 12. And let me summarize. From EMC point of view, if you have a PET tolerant aircraft, you can use, you can transport all these tracking devices, and you do not need to perform another analysis. If your fleet includes aircraft without PET tolerance demonstration, you might check the information package from the tracking device manufacturer and look into specifics from your local aviation authority. Third, I think that the RTCA and EuroCase standards actually allow quite simple EMC demonstration with quite a hard way to get this harmonized, and I think it's rather good. And it also includes cargo tracking devices. And while the guidance for the PET tolerance is widely accepted by the authorities, I would wish for some more acceptance, recognition of authorities for the cargo tracking device chapter as well. And I see when I talk to customers or to our customer service, I see there's a real amount of misunderstandings, which I think is due to the really high amount of mostly outdated material. There's the ARC report from the FAA, there is the info sub from the FAA, and then there's all the old standards, which are ED 130 before issue A and so on. And from my point of view, the most important thing here for the working group or the committee of the IATA is, please do not create another standard, just refer to the right ones. And that is everything from my point. Thank you very much.
Thank you very much, Timo. And yes, we hear you. So we will help airlines and as well as device manufacturers to understand what are the latest regulations and standards to comply with. So this is really the aim of the recommended practice we are going to deliver in the upcoming months. Sorry, we are a little bit late, but we had several questions. So let's start with how many non-Earth airplanes are in use all over the world, and how can a forwarder know if an airline uses a non-Earth compatible airplane for shipping?
Yes, that is an interesting question. I have no idea how many it is. Of course, I'm just the EMC guys, but that is why I said if there's two ways. One is how should I say that? The forwarder does not know. So for them, I think the best way would be to use PEDs that have been analyzed as per PED, as per tracking device evaluation, as I said on page 9 or page 10. So I think this is the safest way for someone who wants to have a tracking devices on a freight, on a piece of freight, on an ULD or whatever, to use such a device. And this is also why I would really like to have the also included in this the switch-off mechanism. So I would say that. From my point of view, it would be good if the authorities recognize that an equipment which is switched off by two independent means is safe enough to be transported on any aircraft, especially since we know that we call them non-HERF aircraft in the standards, but they are actually non-HERF. They are actually flying every day in the HERF environment. It's not that we fly unsafe aircraft. The opposite is true. All the aircraft that fly these days are safe, which you can see. You hear in the news when an aircraft is not safe. So even those aircraft which are classified as non-HERF, okay, they have mechanical steering and additional stuff that has been installed now, which is electronic, is tested against HERF as well. So I think this gives enough reason to accept even 3G, 4G tracking devices, which has means to switch off. Okay, I don't know if this really answers the question, but of course I cannot answer the question to how a freighter can a freight forwarding company can know on which aircraft the device will be transported.
Okay, thank you. So we have also another question. Is Airbus considering implementing wireless avionics intra-communication standards-based infrastructure for communicating to cargo tracking devices?
And that is a topic. I'm sorry, I'm not inside that. I'm the EMC guys. Could also answer a question about lightning protection.
Okay, thank you. And so maybe one last question, which is why is the freighter owner's responsibility to conduct such an important test?
Yeah, it's a question to Maite. But if you own an aircraft and you operate, actually not the owner, the operator, I have to say, I might have said owner, but the operator is responsible for the safe operation of the aircraft.
Yeah.
So you either perform the test yourself, or you buy the aircraft with the test already performed, or you ask an MRO to perform the test for you. So yeah, there's ways to do it. Huh?
Okay. Well, thank you very much for your presentation and answering the questions.
Thank you.
Now we'll move to the end of this webinar. So thank you very much for attending. We have a whole series of webinars. Sorry, this was the episode 4. The next one is on Tuesday on customs made, and we'll have the 5th episode on the One Record Hackathon. So thank you very much, everyone, and thanks again for joining us today, and we will see you next time. Feel free to check out our websites, and bye. Thank you very much.